Definition here. A chi-square independent test is used to test the independence of two variables. Using this test, you can determine whether the occurrence of one variable affects the probability of the occurrence of the other variable. To perform a chi-square independent test, these conditions must be met. First of all, the observed frequencies must be obtained using a random sample. Each expected frequency must be greater than or equals to 5. If these conditions are met, then the sampling distribution for this test is approximated by a chi-square distribution with degrees of freedom R-1 times C-1. R and C are the number of rows and columns, respectively. The test statistic is chi-squared equals to the summation of observed frequencies minus expected frequencies to the second power divided by expected frequencies. And these are the guidelines. You need to verify that you have a random sample and expected frequencies at least 5, identify the null alternative hypothesis, identify the level of significance, then the degrees of freedom, which is R-1 times C-1. You can use a table or you can use your calculator to find p-value and check to see if the standard test statistic is in the rejection region or not. For example, the contingency table shows the result of a random sample of 2,200 adults classified by their favorite way to eat ice cream and gender. The expected frequencies are displayed in parentheses. At 1% level of significance, can you conclude that the variables favorite way to eat ice cream and gender are related? Well, the gender, male and female, two categories here, and favorite way of eating ice cream using cup, cone, sundae, sandwich, other are listed here. Very good. So these are the information that we have. How do we run the test? To run the test, first you need to list all observed values, then expected values, find the difference between observed and expected, raise it to the second power, and divide it by the expected. Add them all together to find your chi-square. Null hypothesis is the variables favorite way to eat ice cream and gender are independent, and alternative hypothesis says, well, they are dependent, and this is the claim. We're going to check to see if we need to reject or fail to reject the null hypothesis so we can make a decision about our claim. Perfect. So as you can see in the observed column, we list 529, 300, 204, 24, 80, and then we go to the next category, 410, 335, 180, 20, and 55. The expected is going to be in parentheses 546.55, 346.36, and so on. All of them are listed here. Then you find the difference between them. You raise these to the second power and you divide it by the expected. So each difference raised to the second power divided by expected. And when you do the calculation, it is 23.487. Note that 23.487 is in the rejection region. Since it's in the rejection region, you're going to reject the null hypothesis and you're going to support the alternative hypothesis. There is enough evidence at 1% level of significance to conclude that the variables favorite way to eat ice cream and gender are dependent.